All right, lesson 9. First question, candle's burning starts out 12 inches long. After 1 hour, it's 10 inches. After 3 hours, it is 5.5 inches long. When do you think the candle will completely burn out? Now, it does say think, so it's not asking for concrete. Candles may not all burn at exactly the same rate. But it seems like the easiest place to get that info or a guess here is that first couple of sentences. Goes from 12 to 10 inches. Okay, in an hour, right? So rough estimate, how many inches does it burn down in an hour? Yeah, 2 inches went down in an hour. So if we use that, just say it burns at the same rate, right? Hypothetically, you have a 12-inch candle, how long until it burns out? 6 hours. Roughly, I can get by with saying about 6 hours. Now, is the height of the candle a function of time? Okay. If it is, that means every time you check it after a certain time, it can only be one height. Right? So the candle you're burning, if you check it in an hour, there's only one possible height it can be. That would be true, right? It can't be two separate heights after an hour. So I'm going to say yes, it is a function of time. Now, do you think it's linear? Do you think it burns at exactly the same rate all the time? I'm going to say no as well. And it kind of shows us that here because 3 hours later, it's not burning 2 inches at a time any longer. Otherwise, it wouldn't have a decimal point here. So it is not burning exactly the same, which makes sense. There might be a little hole in the wax, or the flame got higher, or the wick fell off, or whatever. Different reasons for that. Okay, question number 2. Wyatt, would you read the bottom of 77, please?
When the sun was directly overhead, the stick had no shadow. After 20 minutes, the shadow was kind of 7 meters long. After 60 minutes, it was 26 centimeters long.
All right, say that second part again.
After 60 minutes, it was 26 centimeters long.
Is that the last number? Yeah, so this last one is 60 minutes and 24 centimeters. What was the second set of numbers then? Didn't give you 2 sets?
Okay.
20 minutes and 10.5, so this must be 20 minutes and 10.5. Again, not a fan of having to flip back and forth. I was hoping Wyatt would help us out a little more than that. Thanks, Wyatt. So just write those bits of info there. You don't have to flip. All right. Well, we need to figure out, just like the candle, how far is this shadow moving, right? Here's must be right at noon. There's no shadow. And then obviously the sun moves, right? And the stick that we have pounded in the ground is producing a shadow. So that's what they're measuring. So how long after 95 minutes? Well, again, let's figure out how far it's moving, right? Let's figure out the slope. So we're just going to call the first one 0, 0. I always like my time to be my x, so I'm going to put time first and 10.5 centimeters. So remember, to get slope, I subtract my y's. Maybe you need that formula again. Subtract the y's over the x's, rise over run, however you want to look at it. Lucas, can you help me out with 10.5 minus 0? Thank you. Gerhard, can you help me out with 20 minus 0?
20.
Thank you. How can somebody divide that for me? 10.5 divided by 20. 0. Point what? 525. Okay, so that's about how far that shadow is moving a minute. You just figured out the slope, the rate of change, how fast that shadow is moving across the ground. It does say estimate how long it will be after 95 minutes. So how are we gonna get that? Well, it moves 0.525 centimeters per minute for 95 minutes. You just multiply those two numbers together. You get an approximate answer of 49 point what? 875. Okay, so that is our prediction. Again, I can show it's an estimate by putting the little squigglies in front. And maybe you could say about 50 if you wanted to be less specific. All right, number 2, it says after 95 minutes, the actual shadow is 38.5. How does that compare with our estimate? Yeah, I mean, 11 centimeters off. This far? Is that a pretty accurate estimate? No, I would say not. About 11 centimeters off and change. A little over. Okay, is the length of the shadow a function of time? Okay, that means every time you check the shadow at, let's say we check it at 20 minutes, it can only be in one specific spot. Yeah, that's no problem. Is it linear? Do you think that shadow is moving linearly across the ground? Once again, no. Well, we proved it because of how far off our estimate was. All right, if it was linear, our estimate would have been right on. So because we were off so far, it shows it's not linear. 9.3. Taylor, would you read about recycling, please?
In an earlier lesson, we saw this graph that shows the percentage of all the garbage in the U.S. that was recycled between 1991 and 2000.
All right, so how much was recycled? Again, this is a graph we've already seen. Number 1. Zoe, would you read that, please, on the next page?
Sketch a linear function that models the change in percentages of garbage that was recycled between 1991 and 1995.
All right, so we want to predict, we want to have a line that shows what happened between those 4 years. It says from 91 to 95. So I just made a little arrow by where 91 and 95 is. And I'm going to try to draw a line of best fit. Again, line that's close to all of them, not necessarily through them. It kind of averages those 4 dots. Rough estimate, something like that. Okay, so from that line, for which years is our line, our model, good at predicting the percentage of garbage? So which years does that look like that would be a good line to describe what's happening? Do you think it does a good job of predicting what's going to happen with all these? No? So for which years is the model good? Probably just these first 5 dots or so. So from 90 to maybe even 96 would be a stretch. So maybe 1990 to 1996. For which years is it not good?
All the years.
Yeah, all the others. You could be more specific and say 97 to 13. Okay, pick another time period to model with a sketch of a linear function. Okay, so let's try to estimate what's happening with all these. So let's try to make another line of best fit. You kind of tell me how to angle this thing. Sienna, you tell me when to stop. That'll kind of average all those dots. There, that's way above all of them.
Bring the bottom down.
Bring the bottom down. top down?
Stop.
Stop.
Yeah.
There.
Everybody good with that?
Yeah.
Yeah?
Yeah.
All right, we're doing it.
Just stop. It's closer than
That's a great one.
Yeah, it's not bad. It does seem like I have quite a few more below. Maybe we'll lower that just a little bit more, but it's okay. All right, so for what years do you think that line is good then?
None of them.
That's not very nice. Maybe like 95 to 13. All right, I'm gonna write it anyway. Makes Sienna feel good about her line. 95 to 13, we're gonna say it's good. I would say it's really bad at describing when recycling first came on the market here. So not very good from 90 to 94. Again, that is a linear model, a line that represents the data. Pretty simple. All right, take a look at the homework then, starting on 81. Okay, the first one is going to be similar to the candle problem that we did, predicting about the moon. I think you can handle that. Question number 2, not a fan of this going on to the next page and having to flip back and forth, but I think you can handle that for a problem. I guess I don't really have a choice. Question number 3, 3 of them say solve. I'll tell you that you'll get a whole number for A and B, the first 2 there, if you want to make note of that. C, you get a fraction. The last one, you get a fraction. Maybe you want to even do that one together. I'll give you that option here in a minute. Question number 4. I think you can handle that question. And 5, I think you can do as well. Perimeter of the garden. If you want to make a note for 5B, you do get fractions. Okay, 5B is not a perfect whole number. Maybe even draw an arrow on 83 so you don't forget there's a number 5. Okay, would you like to do 3C together, or can you handle that? That's the one that is a fraction. Do it or not? Do it? All right, let's do it. So just a reminder for that first one, your first step would be to distribute. Take 2 times both of those things. All right, get rid of the parentheses. That's your first step. We're going to do that here as well. So 4 times 2A, please. 4 times 2. 8 times 2. 8 times negative 3A. All right, that's your first step, just like the first one. Yeah, you will get rid of the parentheses. All right, second step, I want my A's on the same side. I prefer that they are positive, so I do not like this minus 24, so I'm going to do the opposite of a minus 24. I'm going to add 24A to both sides. Over here it will cancel out, which is what I want. I do need to add 8A and 24A, and that of course is 32 A's. Still got the 8 and the 16. Hey, looking good so far. 32A, not going to touch that. I do need to get rid of this 8. So I need to do the opposite of A plus 8. I'm going to subtract 8. And now your last step. How do you get rid of the number in front of the variable? You divide by whatever that number is. So I got to divide by 32. 8 divided by 32. You could reduce it and give it as a fraction. Or somebody said a decimal, which is fine as well. there is your answer. So the first one's gonna be exactly the same. Second one's probably the easiest one. You don't have any parentheses to deal with. Again, if I see a minus, I'm always gonna do the opposite of that first. So this one, I'm gonna add 3a or 3y to both sides would be my first step there. Okay, so 1 through 5, again, don't forget to put an arrow here so you don't forget about number 5 hiding on the next page. 1 through 5 for tomorrow.